Alright, hello 7th grade. Today we're looking at independent and dependent events. And before we get going, I just wanted to make sure that we're all clear. This video goes with the week that starts March 30th. So this one isn't going to be due until April 6th. So if you're working ahead, that's cool. If it is now April when you're watching this, that is cool. If you're seeing this today because Miss P put it up and no, now I gotta go do math, this isn't due until April 6th. This goes with the week starting March 30th. Okay, so now, independent events are mostly what we've been dealing with so far because independent events are events that don't affect each other. Like, if I roll a die and I flip a coin, what I get on the dice isn't going to affect whether I get heads or tails on the coin. Or if I flip two coins, those two coins aren't going to affect each other. Or if I roll three dice, what I get on those three dice isn't going to affect any of what I get on the other dice. Now, they might be bouncing around hitting each other when I roll them, but that's not going to change the probability of what I get on each of those dice. So if your events are independent and they don't affect each other, those are the ones we're dealing with first. So if we have things that don't affect each other. For example, if I have a die and I have a coin with I was trying to draw a face, but the camera looking more like a chicken. Sorry about that. So if I've got a dice and I've got a coin and I want to find the probability of getting 3 and heads. So I need a 3 on my die and a heads on my coin. Now, up until now, we've pretty much been going and listing off, okay, well, I could get a heads and a 1, I could get a heads and a 2, I could get a heads and a 3, heads and a 4, heads and a 5, heads and a 6, tails and 1, tails and 2, tails and 3, tails and 4, tails and 5, tails and 6. And you can do that with all of them. It might get a bit long, but that is a thing that you can do. There are good reasons why you might not want to do that with all of them, especially if you have like 5 dice. So we're not going to have like 5 dice that we're rolling. But if you did, you probably wouldn't want to go through and list off all of your different possibilities. So one way to get it is to go, well, I've got 3 and heads. And remember, if we have that word and there, we're only interested in the thing where both of those things are true. So this is the only one we want. So we've got 1 out of 12. The other way to get that, I'm going to erase this, because the other and a generally faster way to get this is to go, if I'm looking at my die here, my probability of getting a 3 is I've got 1 3 out of 6 things that could happen. So I got a 1 out of 6 chance of getting that 3. And if I'm looking at my coin, I've got a 1 out of 2 chance of getting a heads. So I got 1 heads, and it's either heads or tails. Those are the only 2 things that can happen. And again, ignoring that like fluke thing where you might get it to land exactly on its side. That's not going to happen. That the probability of that is so low we can just ignore it. So if I've got 1/6 and 1/2, the other way to get to that 1/12 is to just go ahead and multiply those. And again, remember, fractions, if we're multiplying, we're going straight across. Straight across the top of our fractions, 1 times 1 is 1. Straight across the bottom, 6 times 2 is 12. So that's another way to get to that 1/12. And in general, that's going to be faster than going through and listing off all of our possibilities and finding how many of those we want. Okay, let's try another one of those. Let's see, I've got a little spinner here. And I've got a dice. Typically, when it's a die, I keep calling it dice. Okay, so I've got a die, and I've got a spinner here split into 8 parts. In case you can't quite see that, or you can't see the colors very well, 3 of those are red, 2 of them are blue, 2 of them are green, and there's one over here that's white. So if you're going, Miss P, you forgot to color in that one. I didn't forget, it's supposed to be white. Okay, so if we want the probability of getting something even and red, if I'm looking at my die, I've got 6 things. And how many of those are even? And again, assuming that it's a normal die going 1, 2, 3, 4, 5, 6. We're not playing with any like 10-sided or 20-sided Dungeons and Dragons dice or anything. Just normal, regular dice. So even numbers would be 2, 4, and 6. So we got 3 of those out of our 6. And then over here, if we want red, we've got 1, 2, 3 things that are red out of our 8 total sections. And again, we can just multiply straight across. 3 times 3 is 9. 6 times 8 is 48. And then we're just going to go ahead and reduce that fraction. I almost went and tried to drag that over like a smartboard. I'm still getting used to not having a smartboard. So now we're going to reduce that. So 9 out of 48. 3 goes into both of those. And if you're looking for factors, it's generally a good idea to start with your smaller number, because really the only things that go into 9 are 3 and 3. So if 3 doesn't go into 48, there's not really any way to reduce this. So 9 divided by 3 gives you 3. 48 divided by 3 gives you 16. And there's nothing else that goes into 3 besides 1 and 3. 3 doesn't go into 16, so we're good there. So yeah, 3 out of 16. Now, this section, if you left it like this, I'm not going to dock you points for not reducing that fraction. Just a heads up that if you're double checking your answers in the back of the book, they will have this, not this. Alright. Well, if we want 3 and not white. Okay. So watch out for, even though we want a 3 here, we don't want to put that 3 on top of our fraction. We want the probability of getting a 3 out of our 6 things that are on that die. And out of our 6 things, only one of them is a 3. Because we went 1, 2, 3, 4, 5, 6. One of those things is a 3. And again, our spinner has 8 sections. And we want the probability of not getting white. So I want to know how many of those are not white. So yeah, 1, 2, 3, 4, 5, 6, 7 things there that are not white out of our 8 things total. And again, straight across, 1 times 7 is 7. 6 times 8 is 48. And that one's not going to reduce, because the only things that are going to go into 7 are 1 and 7. 7 doesn't go into 48. Technically, 1 goes into both of them, but if you divide those by 1, you'll get the same thing right back. Okay, so those are independent events, and most of the things we've been dealing with so far have been independent. Now we're going to take a look at some things that are dependent. For example, if I have a little bag with some letters in them, and again, assuming that the probability of drawing each of those letters is the same, so we're ignoring the fact that, like, B is closer to the top here, so if you just reach in, you're more likely to get B. No, we're ignoring that. We're assuming you're, like, shuffling the letters around a bit before you pick one. So I want to know the probability of getting both of them to be A, and if they're dependent, you're going to see a little words here that says without replacement. So if you see those words, that's a big clue that we got some things that are dependent. Because if I reach in here and I pull out a B, and I don't put it back, because that's the without replacement means I'm not replacing it in the bag. If I pull out a B, there's one less B in there. And there's also one less letter in there total. So if I want to know the probability of getting both of these to be A, I've got 2 things that are going on. I want to get an A first and an A second. So if I want to know what are my chances of getting an A first, I want to know how many A's are there. And there are 1, 2, 3, 4 A's. Out of 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 letters. So far it probably doesn't look all that different. We've got 4 A's out of 10 things. But once we have that A, once we've taken that A out, the reason these are dependent is that changes what's left. So that changes my probability of getting an A the second time if I don't put it back the first time. Because now there are only 3 A's. And now there are only 9 letters. So that's the big thing that's different about dependent events, is that's going to change your number of things in your second fraction. So what we get the first time is going to change the number of things over here. And in general, what that's going to do, the bottom number is just going to make it 1 less. So if we have 10 letters and we took 1 out, that's going to give you 9. Okay, now it's the same sort of thing. So now we're just multiplying straight across. 4 times 3 gives you 12. 10 times 9 gives you 90. And then we're looking for the biggest thing that goes into both of those. Now, if you happen to see the 6 right away, cool. If you don't happen to see the 6 right away and you might either like 2 and 3 or 3 and 2, that's fine. Again, that's not the main point here. So if we divide by 6 here, we've got 2. If we divide by 6 here, we've got 15. So we got 2 out of 15, or again, I'm not going to dock you this time for not reducing your fractions. That's not the main idea right now. I'm more concerned that we get to this. If you get to this, cool. If you didn't, if you got here and then you just left it, this one I'm not going to make a big deal out of that. This is the main point right now. Okay. Let's try that one. Let's say we've got a cookie jar. And in our cookie jar, we got 7 chocolate chip cookies, 5 oatmeal, 3 peanut butter, and 5 M&M. And I want to know the probability of getting an oatmeal and then an M&M. And again, assuming that our cookies are more mixed up in this and the 7 chocolate chips aren't right on top or anything, we're assuming that we have the same probability of getting each of these cookies. So again, all the cookies are the same size. We mix them up a bit, which you really shouldn't do because that gets your germy hands all over the cookies. But anyway, assuming that's what we're doing. Don't do that. Assuming that's what we're doing. Then we're looking for how many oatmeal cookies we have. And we've got 5 oatmeal cookies out of your 7 and 5 and 3 and 5. Yeah, that's the other thing to watch out for, is this isn't 1, 2, 3, 4 things. This is, we've got 7 of these plus 5 of these plus 3 of these plus 5 of those gives you 20. So don't start going, okay, well, 1, 2, 3, 4 different types of chocolate chip cookies. Now, if you do that, you'll probably be able to tell right away, because we definitely wouldn't have a 5 out of 4 chance of getting an oatmeal cookie. That doesn't really make sense. That's more than 100%. So usually if you mess up that and do something like that, usually you'll be able to tell whether your answer is reasonable or not. Okay, and then M&M. Now, once we take that oatmeal cookie out, so if I don't have 5 of them anymore, now I've got 4. Now you may notice that didn't change the number of M&M cookies. We've still got 5 M&M cookies, so this is still a 5. But it does change the total number of cookies. So now instead of 20, we have a 19. So watch out for that. That didn't change our number of M&Ms, but it did change our total number of cookies. And then multiplying across, 5 times 5 is 25. 20 times 19 is 380. And again, dividing by 5, so we got a 5 here, and we've got a 76 here. That is not 76. Yes, it is. I think it is. Yeah. 380. 5. Yeah, I was right. Okay. So this is 76. Again, that's not the main idea. I'm more concerned that you get here. Now, if you happen to notice back here that you could also, well, 5 out of 20 is really just 1 out of 4. You can save yourself a little bit of reducing once we're here. So either way, you'll get the same thing. I'm more concerned that we can get to one of these. I'm not going to be terribly picky about which one. Okay. So either that or that. Now I want to know, what are our chances, and I'll put this oatmeal cookie back here. We want to know, what are our chances of getting both chocolate chip? So for the first one, we've got 7 chocolate chip cookies out of our 20 cookies total. For the second one, if we got a chocolate chip, now there are only 6 chocolate chip cookies left. And now there are only 19 cookies total. So that's always going to do that to your bottom number, sometimes going to do it to your top number. So it's going to subtract 1 from your top number if we wanted 2 of the same thing, because there's going to be 1 fewer of that left. Same sort of thing with the overall one. We've got 1 less chocolate chip cookie, and we've got 1 less cookie total. Okay, 7 times 6 is 42. 20 times 19 is still 380. And I'm pretty sure it's just 2. So 2 goes in here 21 times, 2 goes in here 190 times. And 3 doesn't go there, 7 doesn't go there. And again, if you happen to notice back here that 2 goes into both 6 and 10, you can save yourself a little reducing. If that's confusing, not the main point right now. Either of these things would be okay. Just be aware that if you're double checking your answer in the back and they got this and you got this, that's okay. They're the same thing. Or, I mean, if you turn them into decimals, you could do that. Most of these aren't going to turn into particularly nice decimals, so I wouldn't, but if you did, that's okay. Alright, let's do 1 or 2 more of those. So, same sort of thing. So again, we're assuming that this is without replacement. So if we're not putting the cookies back, which you shouldn't, because I'm assuming you're taking them out so that you can eat them. So if you eat a cookie, please don't put it back afterward. That'd be messy. Don't do that. Okay, so if I want the probability of getting an M&M and then a chocolate chip, we've got 5 M&M cookies out of 20 total cookies. And we've got 7 chocolate chip cookies out of, if we take away one of our M&Ms, and again, that doesn't change our number of chocolate chips, but it does change our total number of cookies. So if we're looking at dependent events, your number here should always be going down 1, as long as they're dependent events, which is going to happen if you see these words without replacement. So if we're not putting the thing back. Okay. And then once we're here, 5 times 7 is 35. 20 times 19 is still 380. I can count 3s. Okay, and again, 5 is going to go into both of those. And again, if you happen to realize that back here and you turn this into a 1/4, yay. If you don't realize that, that's okay. Not the main point right now. So you got either 35 out of 380 or 7 out of 76. Just be aware that the back of the book will have this, not this. Alright, and now I want to find the probability, let me put this cookie back, that neither of those is peanut butter. So, if we've still got 20 cookies to start off with, and want to know how many of them are not peanut butter, well, you could either add up 7 and 5 and 5, those aren't peanut butter, and that'll give you 17, or you could take your 20 total minus your 3 that are peanut butter, and then we've got 17. Now, if we take out one of those that's not peanut butter, I don't really know which one of these to take away, but we do know that it's going to give us 1 less cookie and 1 less thing that's not peanut butter. So we don't know which one it is, but we do know that now there are only 16 things left that aren't peanut butter, rather than our 17 that we had back here. Okay. 20 times 19 is still 380. 17 times 16 is not what I know off the top of my head. 272. And again, if you happen to realize back here that 4 goes into both of those and you did a little bit of this, that's fine. If you reduced it once you're here and you divided that by 4, 272 divided by 4. Alright, so 272 divided by 4 gives you 68, and 380 divided by 4 gives you 95. And in either this or this, I'm not going to be overly picky about which one of those you have. That's not the main point right now. The main point is, are things independent or dependent? So watch out for on the homework before you start plugging any numbers into your calculator, figure out whether your thing is independent or whether your thing is dependent. And if it's dependent, watch out for that bottom number should be changing on your second fraction. All right. Go ahead and check out the homework in the description, and remember, this one's due on April 6th, not March 30th. April 6th. Alright, and I'll see you next video.